Hi everyone, this is Himanshu and in this lecture we will study about the few space exploration missions which were conducted by the ISRO. So the first one that we're going to talk about is the ASTROSAT. Now the ASTROSAT is India's first dedicated multi-wavelength space observatory. Now, it studies the outer space objects, most importantly in X-rays, which limited optical and the UV spectrum. It has been placed in the LEO. So, what I have done, I have listed a list of those missions which have been conducted by the ISRO and a very important point associated with them, so that you don't have to read each and every one of them by going through their Wikipedia or the ISRO site itself. So these are the mostly important thing, and I think they won't ask you more than this, but this is quite a good enough information for these things. Now coming back to the astrosat. Now the first thing is that when we talk about that, it studies the X-ray. Now in the application, it's pretty much obvious because the X-rays are emitted by the neutron stars. So definitely this will study the stars. So one of the application will definitely be studying the star, studying the binary system of the star and the regions where the stars were born. So this is what the astrosat is about. The second one is about the EXPOSAT. Now, EXPOSAT has been designed to be a successor of the ASTROSAT, and it is also the same as a multi-wavelength, but it will study the deep space. So this is what it makes different from the ASTROSAT. Now, the third one is basically the MANGALYAAN. The MANGALYAAN, the probing that's called the Mars orbital mission, which was sent in 2008 and 9, basically studied the three main things, that is the morphology, mineralogy, and the atmosphere. Now, for the morphology and the mineralogy, they have used the thermal imaging spectrometer, whereas for the atmosphere, as you know that Mars has a huge amount of methane available, so they have a methane sensor over this thing and a photometer. So this is what the Mangalyaan was about. But the Mangalyaan 2 mission has been planned to be launched in 2024. It will have its own lander mission also, which will study the geology, the magnetic field, and the interplanetary dust. So these are the three things that you can remember. The fourth one is basically the Chandrayaan 1. Similarly, the Chandrayaan 1 that we have sent in 2008 and 9, basically the first mission to the moon, and basically it does the lunar orbiter, and it found the evidence of the water molecules for the first time. Now the Chandrayaan 2, so there are a few things which make the Chandrayaan 2 different than Chandrayaan 1. Was the first one that it consists of not only the orbiter, but it also consists of the lander as well as the rover. So these are the three things that it consists of. Now in this thing, and the very important thing is that the Chandrayaan actually tried to land on the south pole of the moon's near side. Now we are the first one in the world who have attempted to reach there, but unfortunately because of the software glitch, that Chandrayaan 2 was quite unsuccessful over reaching that place. Now it has the three parts, basically the orbiter, lander, and the rover. Now the orbiter is something which is basically placed in the 100 km above the moon's surface. It consists of the soft X-ray spectrometer for the mapping of the element. It will contain an SA radar. SA is basically the synthetic aperture radar, and it is generally used to collect the evidence confirming the presence of water, ice below the shadowed region of the moon. So this is where the SA radar comes to the picture. The spectrometer is there, which is called the neutral mass spectrometer. That is a chase 2 to study the lunar exosphere. And then there's a training mapping also camera for the 3D map of the moon. So these are the few things that orbiter can have. So it's pretty much you can use your common sense here that if the orbiter is at a distance of 100 km from the moon, so obviously it must have a radar, right, to collect the evidence of the presence of water, ice molecules. Apart from that, it will have the spectrometer, because spectrometer is something which is placed at a certain distance, and yes, the camera will be placed at a certain distance. So these are the things that you should keep in mind. Now the lander is what we call as a Vikram. Now the Vikram will consist of a seismometer. Now it has been integrated module, and it will study the moonquake. So the job of a seismometer is basically to study the moonquakes, right? The seismology is basically reading the precessions and the movements in the earth. We use seismology, and the people who do that's called seismologists. So the seismometer is basically used to measure the quakes. So we will use the Vikram to measure the quakes on the moons. Similarly, the rover is there. The rover will contain of the last induced breakdown spectrometer. It's called the LIBC. I repeat, the laser induced breakdown spectroscope. Apex is basically alpha particle induced X-ray spectroscope. So you can remember there's the libs and the apex. So that's more than enough for this thing. So both of them are basically the spectroscope. Apart from that, when you talk about the purpose of the Chandrayaan 2, so the first purpose of the Chandrayaan 2 was basically to find the traces of water and the helium-3. So I think I missed it here, so I'll write it here. The first one basically to find the water and helium-3. So we have to find traces of these things. The second purpose was for the chemical analysis on the surface. So you can write it here that chemical analysis shall be done. And the third thing was basically to send the pictures to the Earth via the orbiter. So these are mostly the purpose of the Chandrayaan 2. The next one in the list is basically the Chandrayaan 3. Now the Chandrayaan 3 is designated to be launched in future. It will be same at the southern hemisphere of the moon surface, but its most of the details have not been in the public yet, but definitely. And apart from that, the few thing is that it will also use the GSLV Mark III rockets, and it is a first ever mission to land a rover near the lunar south pole again. So this will be pretty much same to that. Apart from that, the next thing is that what is the significance actually when we say that we are doing a lunar exploration, then why do we usually do this thing? So that's important to know. Now the first thing is that the lunar mining. Now study of the lunar soil and hence its geology and mineralogy will help the future missions to moon, a possible research station on the moon. So this is what we want. By studying this thing, we can have our own research station at the moon itself, because the US and China have plans to set up a research stations on the moon south pole by 2024 and 2029. So that's why why should India lag behind? India should also go there, and this is why we are doing a lunar mining. Apart from that, the next is basically the potential source of the in-space fuel. That is basically the presence of the volatile compounds on the moon is a potential propellant for the rockets in space. So which if explored, it made the usable and help the deep space missions with higher payloads. So this is where we can use it. Now the third thing can be the source of the energy security for the future. Now the presence of the helium-3 actually has sparked the interest for the potential source for the nuclear fusion and energy security for future. Now once the moon's far side is explored, we can station the space-based telescope on the moon for better astronomical observations also. So yes, we have a different thing we can do, and the fourth thing, that is basically the source of rare earth metals can be found there, because there was one element called the lanthanides, I think. Let me write it here. Lanthanides, scandium, yttrium, which can be used as a modern electronics. So we have these things available on the moon itself. So that's why it is very highly significant, basically to perform the lunar exploration mission. So that's why we are doing it. The next one in the list is regarding the Aditya. That is in Aditya 1 and Aditya L1. Now these are the India's first mission to study the sun, and it has to be launched in early 2020, but I think it's still not yet launched. So this is the main thing, and this will study the sun. So there is a difference between here the Aditya 1 and Aditya L1. The Aditya 1 is mostly study the sun corona, whereas the Aditya L1 will not just study the corona but the chromosphere as well as the photosphere. Now when we talk about these things, basically when we say the additional information, the corona ejects 1 million of tons of high speed, and actually if you know the corona what means, if let me make somewhere a diagram here. If this is a sun, right, and this is a surface, right? Now this basically a layer which is outside. Now this is a surface, this is a layer. Now this outside surface where the heavy radiation take places, now this zone is basically called the corona, whereas this is a surface. Now the mystery about this thing is that the corona is actually a very high temperature, more than I think more than the 1 million degrees Celsius. That is basically the temperature of the corona, whereas the surface of the sun is much cooler as compared to the corona itself. So that's a mystery. That is why we have sent the probes basically to study such thing, that why such thing is happening. So this is what the corona is about, and we will learn about these things, corona, chromosphere, photosphere, more in the geography chapter when we study about the the beginning of the universe and everything. So it will repeat there also. So right now you just have to remember that yes, there's something called the corona, chromosphere, and the photosphere. Then we have a Gaganyaan with us. Now the Gaganyaan would be the India's first human spaceflight mission. Now it's India's first, but not in the world, because in the world we are the fourth one. Before us there is a US, there is a Russia, and there is a China. And it will consist of the two flights at very first, which will be unmanned completely. It will be in the LEO orbit, that is basically the 400 to 600 kilometers. And then when we have a successful flights of the two unmanned, then we will send these 3 astronauts for the 7 days. For this we will use the GSLV Mark III rockets, as we have already discussed these things. And most importantly, there will be a crew module. The crew module is basically the atmospheric re-entry technology that we gonna use. Now generally what happened when we send a communication satellites or the IRS satellite, we generally don't bring them back to the Earth's surface. But when we are sending the human probes, so obviously we have to bring them back. Now in bringing back, there's a huge amount of the friction in the atmosphere which take place, and because of that there's a the space shuttle reaches to a very high temperature, and it becomes difficult for the humans or the space shuttle itself to bear that amount of temperature. So in order to make that system work, there is a crew escape system which has been developed, which is basically act as an emergency accident avoidance measure. So what it will do, it will maintain a steady cabin pressure and the air composition. It will remove all the carbon dioxide and other harmful gases. It will control the temperature and humidity, and it will manage the parameters like fire detection and suppression. So yes, we have tested this thing, and we will surely implement this thing in the Gaganyaan. So this is mainly about the Gaganyaan itself. Nothing much important, but important in respect of its various specifications, like the LEO is there, GSLV Mark III is there, what is the position of India in this thing, what is a crew model. So they can ask you in the prelims these things. And connected to this is basically the Vyommitra. Now recently the ISRO has made a humanoid robot which they will send as a test flight for the Gaganyaan. So the basically it is called the Gyod. The Gyod is basically a female humanoid which they will send as basically a test purpose, or more like a drill, that how this thing performs. So this is mainly about the Gaganyaan here. And the next is we're gonna discuss about is basically the SHUKARYAAN. Now the SHUKARYAAN has been in the news recently. It is basically the sugar and basically the Venus is what we say. And here we will send a probe, and it will study the 3 different things about the atmosphere, about the surface, and about the solar radiations in that place. Now the Venus is really an interesting planet because there is so much similarity with Earth. For example, like as Earth, this is also a solid planet. It has the same size as Earth, but however it has a 95% of the carbon dioxide and the very high greenhouse gas effect because of this thing. Apart from that, it is the only planet where the rotation period is longer than its orbital period. Now this is important. Its rotation period is longer than its orbital period. So that's really interesting. And apart from that, it shows a retrograde rotation. Now if you know what does a retrograde rotation means, that it is the only planet which spins in the direction opposite to the direction in which it orbits the sun. So I repeat again, it spins in the direction opposite to the direction in which it orbits the sun. So the sun would rise in west and set in east on Venus. So that's what is interesting in it. And due to basically a slow rotation, the global magnetic field is very much low on the Venus. So these are the few things that you should remember. They can ask in the prelims. Apart from that, there's a NISAR. NISAR was in the news from the last 2 years, I think. It is basically the NASA-ISRO synthetic aperture radar, and it's a joint program of the NASA and ISRO, and it will study the natural processes like ecosystem disturbances, the ice sheet collapse, the natural hazards, and etc. So this is majorly about the NISAR itself. Apart from that, there are few observatories like the Paris observatories are there. The Paris is basically the PRL Advanced Radial Velocity Abu Research Spectrograph. So if you read about the Paris, that it has been designed by the PRL. There's a physics research laboratory in Ahmedabad itself, and its main aim is to search for the exoplanet around the dwarf main sequence stars using the radial velocity method. The exoplanets are those planets which are outside our solar system itself. So it will study for the new planets here. Then similarly, we have one more project which is called the project NETRA. So basically it is an early warning system. Now what was happening at present is that India was relying pretty much on the NORAD, that is a North American Airspace Defense Command, that is basically NORAD, it's mentioned here, and to gather all the information regarding the early warning systems. But now, after the project NETRA, if we have successful deployment of this thing, then we don't have to rely on the NORAD. So here is the NORAD. So this is an early warning system basically we want to establish, and in order to safeguard the space assets, so whatever space satellites we have, we want to make it safe. So that's why we have project NETRA. And in order to make this thing happen, we are deploying the radars and the telescope at different places. For example, like in Aponamudi in Thiruvananthapuram in Kerala, we have one radar. In the Mount Abu in Rajasthan, in the Leh in the northeast, and the multi-object tracking in Nellore. So these are the multiple things that we need to do in order to make sure to safeguard the space assets under the project NETRA. So this is mainly about these things, and in the next lecture we will read about the important missions of the NASA. So thank you everyone.